All right, hey guys. So for the last discussion, the question is, how well can we predict a student's score on the final exam based on their performance in the class from the first 13 weeks of the semester? Okay, so going to the first thing. So we had to show a hypothesis test involving discussion 10 and show all of the 5 steps, which I did right here. This is about discussion 10. So, it's just going to use this. So for the null, I said the discussion grades will have a positive correlation to the predicted exam 4 scores, and meaning they will equal each other. And then for the alternative, I said discussion grades will not have a positive correlation to the predicted exam scores, which means they will not be equal to each other. So for step 2, I said they are all independent scores. There is at least 10 successes and 10 failures, and there's 80 total, so it passes. For step 3, for the signal, what I did is I did the means subtracted by each other, which then I got 14.937. Also, what I did is for this one, I did the discussion and using exam 4 scores. And so this I got for my signal, and then for my noise, I took my standard deviation divided by the square root of 80 and got this number. And then the test statistic, you just take your signal over your noise. And so I got 7.29. Then you find your p-value, and I actually calculated this. It's not letting me click it. I calculated it using Excel. It's just not letting me click it. So here, as you can see, I got a very small number. It wouldn't even let me not use scientific notation, so it's a very small number, meaning they're very unlikely to be correlated. So then for step 5, I said the p-value is extremely small, which means there's not a high correlation between the discussion grades and the predicted exam 4 scores, and I said I'm just going to reject the null. That is how you can see I did the discussion. The next one, it says for hypothesis testing involving quiz 10 and exam 3, you only need to show steps 3 to 5. So let me show you that. Here I did the same for quizzes. So I started at step 3, and the signal, I just subtracted the means from each other. And then I got this for my signal. I'm taking the quiz score and subtracting it by the exam. I did the same for this. I did my x subtracted by the exam. So this is my noise, which is a standard deviation divided by the square root of n, which I get this, and my t-test statistic, which is signal divided by the noise, and I got this. So then my p-value, also I got a very small value. I also used Excel, so I got a very small value, as you can see here. And then for my step 5, I said I'm going to reject the null. My p-value is too small, so quizzes and the exam scores do not have a positive correlation and will not give you a 0. They're not the exact same. So for exams, I did the exact same thing. I calculated my signal, my noise, and my t-test statistic, and then my p-value, which is also very small. So again, I'm rejecting the null. The test grades are not a good representation of what the student will get on the final, but as you can see, my p-value is quite bigger than the other two, so if I had to choose, I would choose exams as to look at for my personal opinion. Okay, so for the next one, I chose, this one. Okay, so we had to do a 95% confidence interval. And so here I did the 95% confidence interval for my quiz. So here I did 0.0336 plus or minus our t-value times our SE. So for the t-value, I went and I used the degrees of freedom, and I went and found that it's 1.99. So for the upper side, it's 0.331702, and for the minus side, it's negative 2.94742. But the interesting thing about this quiz is it includes 0. So since it includes 0, we have to accept the null. I remember learning that, so let me know if that is correct or not. So for that one, I accepted the null, and here's the confidence interval planted. Okay, so then I said we are 95% confident that the quiz 1 through 10 score affects the final exam scores in this region, just because it did go through 0, so in that case we have to accept it. So for the next one, I did the exams. I did the same thing, and my upper is right here, and here is my lower. And I said we are 95% confident that the exam 1 through 3 scores affect the final exam scores in this region. This one doesn't include 0, so I'd probably reject the null, just in general. Okay, so for the next one, I'm using the change in R-squared values from the simple linear regression to your chosen multiple regression. So for the quiz, I'm going to go here to the regressions. So for the exam, discussion, and quiz R-squared, I got 0.57. For just exam and quizzes, I got 0.54, and this is each of them. So for the quizzes, I got 0.32. For the discussions, I got 0.17, and for the exams, I got 0.54. So I'm sure you're asking, what does that explain? I'll get to that later. So for the quiz, I got 0.32 for my R-squared. For the discussion, I got 0.17, exam 0.54, and multiple 0.57. Okay, so for the next one, it says use the change in R-squared values from the simple linear regressions, your chosen multiple regression. So the simple linear regression, like I said, had an R-squared value of 0.32 for quiz 1 through 10, 0.17 for discussion 1 through 10, and 0.54 for exam 1 through 4. That's all seen in our quizzes. I'm just interpreting it. The chosen multiple regression had an R-squared value of 0.54 for exam 1 through 3 and quiz 1 through 10. And the multiple regression had an R-squared value of 0.57 for exams, discussion, and quizzes. Okay, so moving on. It says how much of the variability in exam 4 scores can be explained by discussion 10 considered alone. And for this, you just look at the R-squared value of discussion, and that's 0.17, which is 17%. Okay, so then the next one, how much additional variability is explained in discussion 10? So this one's basically asking how much is discussion 10 contributing, and for that I did 0.56 minus 0.54 to give me 0.02, which is 2%. And then for the next one, it's saying how much is the discussion based on all of this additional stuff, and I got 0.57 minus 0.54, which is 0.03, which is 3%. So for the next one, number 4, what I said, for number A, I said, this is very accurate. The professor is incorrect. The correlation has always been very close from the expected from using the exam scores. Also, the exams had a higher R-squared value, which means that the data covered a higher percentage than the others. It had an R-squared value of 0.54, meaning that the exams account for over 50% of what extent the variance of one sample exams explains the relationship between the other variable exam 4. So basically it's covering more than 50% of what the variable of the exams is, the relationship between the variable of exam 4 score. So that's a high score. So that's why I'm saying that the professor is incorrect. And for B, I said I think that doing well on the discussions does help the students' overall grade and learn the material faster, but looking at our equations given, exams had the best chance of indicating the final exam score. So that is my final answer, and let me know if you guys have any other questions. I'll just let you guys look through all of this. Here's my confidence interval, and yeah, just let me know if I should change anything. Thank you.